Hello everyone, I'm Judge Zhang. Today I'm going to present zero knowledge proof uh, and its applications in blockchain. Here's today's agenda. Firstly, I will introduce the blockchain and I will illustrate some blockchain problems and possible solutions. Then I will introduce zero knowledge proof and I will explain some zero knowledge proof applications in blockchain. And lastly, the future work. The blockchain definition. Blockchain is an open, immutable, and distributed ledger that facilitates the process of recording transactions and tracking assets in a network. Blockchain mainly contains three. A blockchain mechanism mainly contains three parts: cryptographic keys, proof of work consensus algorithm, and peer-to-peer network. Cryptographic keys consists of two parts: private key and public key. And these two keys perform successful transactions between two parties. They can also produce secure digital identity reference. The secure identity is the most important aspect of blockchain technology. Proof of work consensus algorithm. It is used to select a miner for the next block generation. And the blockchain using this proof of work consensus algorithm as well. The main idea behind this algorithm is to solve a complex mathematical puzzle and give out a solution. And lastly, the peer-to-peer network, P2P. It is a distributed application architecture that partitions tasks or workloads between pairs, and peers are equally privileged participants in the network. There are also some benefits of the blockchain. For example, distributed, secure, transparent, and flexible. The distributed ledger is shared and updated with every incoming transaction among the nodes connected to the blockchain. And all this is done in real time because there are no central server controls all the data. And secure. There is no unauthorized access to the blockchain. It is possible by permissions and cryptography. And data stored in blockchain are immutable. Transparent, because every participant in blockchain has a copy of the blockchain data, so they have access to all transaction data, and they can verify the identities by themselves. Flexible. The smart contracts can be executed and written into the platform, and the blockchain network can evolve in pace with business processes. However, the blockchain has some security and privacy problems as well. Because the transaction data, including implementation details and transaction amounts, transaction address, and account balance, they are all stored in the blockchain. And due to the openness and transparency of blockchain, anyone can access this transaction data. So, some security and privacy challenge may arise, and because some malicious attack, yeah. And there are some possible solutions to these security and privacy problems. For example, homomorphic encryption. The homomorphic encryption supports certain types of operations to be carried out on the several types without decryption. It can protect the security of the account balance and transaction amount. However, it cannot ensure the security of the account address. And the ring signature. Ring signature is a special digital signature, and it does not reveal who signed it, so it protects the security of the account address. However, it cannot guarantee the security of account balance and the transaction amount. Secure multi-party computation is another secure solution. It is a cryptographic protocol. It distributes a computation task across multiple participants. It can protect the security of account balance and transaction amount, but it cannot protect the security of account address. Moreover, all these three methods cannot be used to verify whether the prover has enough transaction amount without leaking information. We can introduce the zero-knowledge proof. It is a better solution for the privacy and security problem. The zero-knowledge proof, ZKP, is an interactive verification protocol. It requires interaction between the prover proving their knowledge and the verifier validating the proof. It is a method by which the prover can prove to the verifier that a given statement is true, while the prover do not need to reveal any additional information. It is challenging to prove such possession without revealing any information. So let's see the zero-knowledge proof framework. As shown in the figure, there are two entities, prover and the verifier. And the implementation of this framework consists of three phases: witness phase, challenge phase, and response phase. Witness phase, the prover computes a proof that contains its statements, and the proof can be transmitted to the verifier. And witness phase, the prover computes a proof that contains its statement. The challenge proof. The verifier asks the prover several questions, and finally the response phase. The prover answers the question, and the verifier can accept or reject the generated proof. In the above phases, no private data will be leaked. And the framework has three properties: completeness, soundness, and zero-knowledge. Completeness property means that the verifier will always be convinced of the prover's true statements. In other words, if the prover can prove his statement is true, the verifier will always accept that proof. And soundness property means that the verifier cannot convince the verifier that his false statement is actually true. In other words, if the prover's statement is false, the verifier will reject that generated proof. And lastly, the zero-knowledge property can be used to guarantee that the prover does not leak any useful information to the verifier. In other words, if the prover can prove to the verifier that his statement is true, the verifier will always accept the prover's. The verifier will learn nothing except that the prover's statement is true. In other words, the prover do not revealing other additional information. And I will introduce a famous zero-proof model, ZK-SNARK. ZK-SNARK stands for Zero Knowledge Succinct Non-Interactive Argument of Knowledge. It is an improved ZKP mechanism. And ZK-SNARK ZK-SNARK is a proof construction where one can prove the possession of certain information without revealing and without any interaction. zk-SNARK mailing contains a three-step setup, prover, and verify. For the setup step, it's a procedure that guarantees the proving key and the verification key. And zk-SNARK has some characteristic. Firstly, the verification can be executed within a really short time. Secondly, the prover and verifier are not required to communicate with each other synchronously. In other words, no requirement for immediate interaction between two parties. And lastly, the prover algorithm can be implemented in a polynomial time. And another famous lightweight zero-knowledge argument model is Allegro. There exists a proportional relationship between the computation complexity and the square root of the size of the verification circuits. And it also supports any hash function that can resist collision. And moreover, Allegro can be a zk-SNARK schema in random Oracle model. And it can be applied for extremely large verification circuits as well as medium-large circuits. And zero-knowledge proof applications. I will introduce three main applications: anonymous verifiable voting, secure exchange digital assets, and secure auction. Firstly, anonymous verifiable voting. Voting is essential to guarantee democracy in countries and companies. However, the privacy of voters may be leaked during the process of voting, and the voting results is difficult to verify securely. So ZKP is an available approach to this problem based on ZKP, because ZKP allows voters to show rights without leaking identities. And the secure exchange of digital assets. Digital assets are uniquely identifiable. If people want to exchange their digital assets, their privacy may be leaked during the exchange process. Based on ZKP, the digital assets can be exchanged without leaking the user's privacy. And ZKP, because ZKP can generate verifiable proof that contains the process of exchange of digital assets. Secure auction. During auction, the government chooses the lowest bids from multiple suppliers. However, during the selection of winning suppliers procedure, the losing suppliers' bids and identities may be leaked. So ZKP can solve this problem because ZKP can generate verifiable proof for each supplier's bid. And zero-knowledge proof framework in blockchain. There are mainly two parts in ZKP architecture: the off-chain and the on-chain part. Off-chain, the prover can claim that they have enough transaction amount, and the validation requester is responsible for announcing a verification task and collecting verification result and paying fees. On-chain, the authenticity verification of the prover's claim is implemented by the verifier. In other words, the blockchain miner. And moreover, blockchain also has an incentive mechanism that can calculate the verification fee for the verifier. And there are some zero-knowledge proof applications in blockchain. First is the Zero Coin. Zero Coin is a cryptocurrency that realizes completely anonymous currency transaction. And ZKP solves double spending problems. Specifically, the double spending is prevented by serial numbers. The serial number is corresponding to the funding in the commitment. Moreover, each participant can track the transactions according to the serial numbers. However, Zero Coin still leaks the destination and transaction amounts information. Zero Cash. Zero Cash is based on the improvement of ZK Snark. It is a full-fledged ledger-based cryptocurrency. And Zero Cash can be paid directly and privately without any interaction. Because it can protect the source, destination, and payment amounts. Moreover, the Zero Cash supports anonymous transaction with a variable amount. And compared with Zero Coin, the size of the transaction and the verification time reduces greatly. Hawk is another important application. It is based on Zero Cash. It's a novel decentralized smart contract mechanism. Hawk can offer both secure transactions and programmability in blockchain. And in Hawk, ZKP can be used to guarantee the validity of contractual execution and funding transfer. BOLT. BOLT stands for Blind Off-Chain Lightweight Transactions. It contains the construction of three secure payment channels in the decentralized cryptocurrency. And blind signature and ZKP are combined to allow users to implement secure exchange of payments without leaking any payment information. Furthermore, a revocation token is used to prevent dishonest users from preserving and using their earlier versions of token. Future work. There are some future work for ZKP. Firstly, weaker assumption. One challenge of ZKP is whether it can be implemented efficiently by using some weaker solutions. For example, ZK Snark can be applied in Zero Cash. However, it needs trusted third parties to set up and initialize system. So I think it is worthy to study some efficient implementation of ZKP without any trusted third party, and incorporation of different mechanism. Different ZKP models have different advantages. For example, in Libra, the running time of the prover is linear, and for Hyrax, it does not require any trusted setup. So, to make better use of this advantage, I think it would be meaningful to study whether these different mechanisms can be incorporated together to a unified and advanced model. And lastly, the strongly linear version of proof. Um, the strongly linear version of proof is a new type of ZKP. It allows the verifier to implement linear query to the input. Furthermore, the query is pointed to the proof, and the verifier owns limited access to the input. So, this new model realizes the standard concept of soundness. Conclusion. In this presentation, I introduce some basic ideas of blockchain, and I also illustrate the openness and transparency property of blockchain cause some privacy and security issues. And I will also introduce zero knowledge proof, the ZKP. I talk about its definition, framework, models, and application. And I also emphasize the ZKP applications in blockchain. Thank you. And here's the citations.